Today, I have a really exciting problem, and we will solve it using two ways. The first one is using coordinate geometry, and the second one is using pure geometry. So, the coordinate geometry solution will be simpler, but the pure geometry solution, in my opinion, is more exciting, and there is a lot to learn. We will be using something called the angle bisector theorem in a very surprising way. So what does the problem say? We have a triangle ABC with a fixed base BC. So BC is a fixed segment, and we have a point A, a moving point A, such that AB over AC is always 1 over 2. AB over AC is 1 over 2. So BC is fixed, the point B and the point C and the segment BC is fixed, but A is moving such that AB over AC is always 1 by 2. We want to find out the path traced out by the point A, or the locus of the vertex A. So the first method, which is faster, is using coordinate geometry. So let's draw a coordinate system such that BC is on the x-axis. We can do that. Such that the coordinate of C is t, 0. Coordinate of B is negative t, 0. So I'm just assuming that the origin is at the midpoint of BC. We can set up the coordinate system in any way we want. And the moving point A, that has coordinate x and y. So for a given BC, t is fixed. It's a fixed number. But x and y are variables. So now we calculate. What we know is, we know that AB over AC is 1 over 2. That's given. So we will use that. AB is square root of x plus t whole square plus y minus 0 whole square, and AC is square root of x minus t whole square plus y minus 0 whole square. And it's given, the condition is the ratio of these two is 1 over 2. Okay, so we have the equation set up. Now we can calculate. So the way we calculate, so let me just erase this. The way we calculate is that we just cross multiply. So 2 times square root of x plus t square plus y square is equal to square root of x minus t square plus y square. And then we can square both sides. If we square both sides, we get 4 times x square plus t square plus 2xt plus y square is equal to x square plus t square minus 2xt plus y square. So if we bring everything to the one side, what we get is 3x square plus 3y square plus 10xt plus 3t square equal to 0. Remember, t is a constant number, x and y are variables. So what should we do? Well, we can simplify further. We can write down it like this: x square plus 2 times x times 5t by 3. So I just 3 times, and this is 3 divided by, so they will cancel off, and we will be left out with 10xt, which we had earlier, plus t square. So I sort of artificially introduced something here. So I'll just calculate it actually separately. So this is actually, I'll put the 3t square separate, and I'll put 25t square by 9 here because I want to complete the square. So I artificially put 25t square plus 9, and I have the 3y square and the 3t square, which is equal to, now I artificially introduced 25t square by 9 times 3. So 25t square by 3. So 25t square by 3 on the left hand side, it was artificially introduced. So I will delete it as well, or I will add it to the right hand side as well. So what do we have now? We have 3 times x plus 5t by 3 whole square plus 3 times y square equals to 25t square by 3 minus 3t square. So this comes out to be x plus 5t by 3 whole square plus y square equal to 16t square by 9, or 4t by 3 whole square. Okay, so this equation is that of a circle. This is an equation of a circle with center at negative 5t by 3 comma 0 and radius 4t by 3. It's the radius, and this is the center. So the center of the circle is on the same line as BC, that is the x-axis. Negative 5t by 3 is the center. So that's somewhere here, maybe a little left of negative t. And it's a circle with center negative 5t by 3 comma 0 and radius 4t by 3. So that is how we solve it using coordinate geometry. But really, this problem is more fun using actual geometry, pure geometry, and I'll show you how to do that, and we will learn a lot by using that method. So let's try that. So again, we will have BC, and we want all such points A such that AB over AC is 1 over 2. All such points A. So one such point, so I just extend this. One such point, or one such position of A will be between B and C, because there will be a point which divides BC into 1:2 ratio. So AB over AC will be 1 by 2 as we want. So if this is x, this is 2x, right? Now there will be another position of A somewhere here, A, such that AB over AC will be 1 over 2. AB over AC will be 1 over 2. And this is exactly where, if this is 3x, right? If this much is 3x, then AB is 3x, AC is 6x. So AB over AC is 1 over 2. So 1 point on the outside or 1 point inside. So it's like that. These are the two extreme points. Right? Now let's take any other point. So these are 2 points. Let's take another position of A. So I'll call them A1, A2, A3. So A3 is another position of A. So we know that A3 over B, A3B divided by A3C is 1 over 2. So if this is y, then this is 2y. A3B, A3C is in that ratio, AB over AC, that's 1 over 2. That's the condition. A3 is one such point, right? Now we can use a very beautiful theorem from pure geometry known as the angle bisector theorem. Notice if I join A1, A3, what I get is that A3B by A3C is equal to A1B by A1C. I'll write that A3B by A3C is equal to A1B by A1C. Isn't that true? Because this is y by 2y and this is x by 2x. Now by converse of angle bisector theorem, A3A1 is the bisector of angle A3. The angle bisector divides the base in the same ratio as the sides of the triangle. The ratio of the sides of the triangle is equal to the ratio of the bases in which the angle bisector divides them. And converse is also true. If a line segment divides the base in the same ratio as the containing sides, then that line segment is an angle bisector. So which means that this is theta. If this is theta, then this is theta. Now if I join A3, A2, the external angle bisector theorem kicks in. External angle bisector theorem kicks in. And let me just extend this yellow line. Then this one is the bisector of this angle. So if you don't remember the angle bisector theorem, you can look it up and external angle bisector theorem in any geometry book. Then this line A3, A2 is the bisector of this external angle of this particular triangle. Okay, which means that this is 90 minus theta and this is 90 minus theta, because the total angle is 180 degree. So this is, if this is 2 theta, then this is 180 minus 2 theta. So each one is 90 minus theta. And we are done, because it says this angle A3 is 90 degree. 90 minus theta and theta. The external angle bisector and the internal angle bisector intersect each other at 90 degree. So this angle right here is 90 degree, which means A3 was a random point in our locus. A3 traces out a circle. Remember, angle in the semicircle is 90 degree. So I'm using the converse of that. It traces out a circle with the diameter A1, A2. Right? Isn't it nice? So I really like this problem because it of course it can be solved more easily using coordinate geometry, but using pure geometry we see something really nice happening and we get a sort of better insight into the problem. So if you like problem solving, then let me know what are your insights about this problem. Put your comments, and if you like these type of problems, please subscribe to this channel. I will see you in the next video.